Welcome to today's webinar. This webinar is on Amazon Managed Blockchain, and today we're going to build an application using Amazon Managed Blockchain. My name is Michael Edge. I'm a blockchain architect with AWS Professional Services, and I'll be taking you through building this application on Managed Blockchain. Let's quickly have a look at the agenda and see what we're going to cover today. The session today is really a mixture of hands-on and discussion. So during the webinar, I'm going to be building a managed blockchain network, and I'm going to be deploying an application and some smart contracts onto that managed blockchain network. I'm also going to be discussing what I'm doing while I'm doing it so that you understand why I'm doing things. And I'm also going to be explaining some of the concepts behind Hyperledger Fabric as we go along. So I will be switching between some slides and between the AWS console as we look at some of the hands-on pieces. So we will be creating the blockchain network, deploying some smart contracts, deploying a RESTful API server, and finally deploying a web application. A little bit more detail to that. Once we have the Amazon Managed Blockchain Network, we will create a peer node in the network, and then we will create a Fabric channel. Once we have the channel, we'll install and instantiate some Chaincode. Chaincode is the smart contracts within Hyperledger Fabric. We'll then invoke some transactions on that Chaincode, and we will query the Chaincode. Finally, we'll build on top of that a RESTful API and a Node.js web application. The end result of all of this is you're going to see a Node.js application that looks just like any other Node.js application. Behind the scenes, it's using a blockchain network, but you wouldn't even know that. It's abstracted away completely by the RESTful API. Right, I'm very happy to announce general availability of Amazon Managed Blockchain. Hyperledger Fabric is available today. Ethereum will be coming soon. And Managed Blockchain is now ready for your production workloads in US East, North Virginia. That's US East 1. You can simply go to the management console and get started. And that's what we're going to do today. So you will be seeing the management console today, and you'll be seeing me using Managed Blockchain. All right, the resources that you need for today's webinar. The most important resource is the GitHub repository. You can get to the GitHub repository in two ways. You can either use your phone and scan that QR code that you see in the bottom right corner, or you can use the tiny URL or the GitHub URL that is posted over here. It's obviously a lot quicker for you to write down the tiny URL, or you can take a photograph of this page, whatever works for you. The blog posts at the top are blog posts that explain parts 1 to 5 that are included in the GitHub repository. So both of those blog posts refer to the README files and to the code that we have in the GitHub repository. So they're there just for your information. Again, you can either take a photo of those, or you can just do a search on the Amazon database blog, and you will find those two blog posts for Managed Blockchain. So hopefully by now, everyone has taken a copy, a photograph, or written down the URL for the GitHub repository. That's what we will be working through today. All right, so what is Amazon Managed Blockchain? We're going to just spend 1 minute very quickly to say that Amazon Managed Blockchain is a fully managed service. Makes it easy to create and manage scalable blockchain networks. And the first release of Managed Blockchain supports Hyperledger Fabric, and we have Ethereum coming soon. Now, when we say fully managed, what we mean by that is that all of the Fabric components are managed for you by AWS. I'm going to show you an architecture diagram a little bit later, and you'll see what we mean by fully managed and where those different components in the network are actually located. All right. So let's get started. What we're going to do is we're going to create the Fabric network on Amazon Managed Blockchain. And while that's in progress, we will then discuss some of the concepts around Hyperledger Fabric, and Amazon Managed Blockchain. Now, before I dig into that, let me just show you which windows we're going to be tabbing between. So here I have my PowerPoint presentation. Then in Firefox, I have my AWS console. So I'll be tabbing through to that. And in Chrome, I have the link to the GitHub repository. This is the non-profit blockchain sample application that is built on Amazon Managed Blockchain. And it is made up of 5 parts, parts 1 through to 5. Today, we are going to do parts 1, 2, 3, and 4. We will build the network, deploy some non-profit chain code to that network or smart contract. We will run a RESTful API server on top of that network. And finally, we will run an application that talks to the RESTful API server. So that's the plan for today. We're going to start with part number 1. So I'm going to click on part 1 here. It's going to take me to the README for part 1. Now, the prerequisites for this workshop is to spin up an AWS Cloud9 instance. We don't actually need the development capabilities of Cloud9. Cloud9 is an IDE, integrated development environment. What we need from Cloud9 is simply the Linux command line. And the reason we use that, it just makes it a lot more consistent. Everyone has the same Linux command line, and we don't have to worry whether people are working on Macs or on Windows machines. So what I'm going to do is I'm going to spin up a Cloud9 instance. And once my Cloud9 instance is there, I'm going to clone this repository here. So I will switch over to Firefox, and I will create a new environment. Now, we can call it anything we like. I'm calling it NGO. The application we are deploying is a non-profit organization type of application, which is really a charity donation system application. NGO is the term used in other parts of the world for that. Now, I'm going to select a T2 medium instance. And the reason for that, I need a little bit more RAM, a bit more memory. The reason I need more memory is I'm going to be running my Node.js application on here as well. And I want to make sure I have enough memory for that. That's the only change that we need to make. Other than that, we just click on the next button. We can review all the settings, and we click Create Environment. Now, that's going to take roughly 30 seconds to create my Cloud9 environment. Once the Cloud9 environment is there, I'm going to clone this GitHub repository here, and then I'm going to update my CLI, my AWS command line interface. I need to upgrade that because we have just released Amazon Managed Blockchain. It went GA today or yesterday, and we need to upgrade the CLI to make sure that we include the Managed Blockchain CLI. So we will be using pip to do that. Pip is already installed on the Cloud9 instance. So it's really just a case of copying and pasting those commands and popping them into your Cloud9 Linux command line. Once we have the command line installed, we're ready to go with Cloud9. We're going to move on to step 1, where we create our Hyperledger Fabric blockchain network. So I will cover those steps in a minute or two. So if we go back to Cloud9, we can see we are connecting now, which means that our Cloud9 instance has been created. Behind the scenes, Cloud9, just for interest, I can show you actually. Cloud9 uses a CloudFormation template, and that CloudFormation template creates an EC2 instance. And you can see the EC2 instance has been created here, and this is where your Cloud9 IDE is running. All right, so my Cloud9 environment is ready. I don't need the rest of this page. I don't need the code editor because we won't be doing any editing using this IDE. All I need is this Linux command line. So I'm going to maximize this part of the window so that we only deal with the command line here. Now, going back to my repository, I want to clone the repository. So I'm just going to copy all of that, Control-C. You can Control-C both lines at the same time, and just come back here and paste them in. All right, and that will now clone my GitHub repository for me. And I'm going to update my CLI as well. Okay, so while that's happening, let's move on to step one. Step one, we create a Hyperledger Fabric blockchain network. So you need to go to the Amazon Managed Blockchain console. I have the window for that already open. If you select Amazon Managed Blockchain from the list of services, then you are going to see a page similar to this. And this will allow you to create a network. There is a lot of useful information on here, such as how it works, how we create networks, how we invite members to the network, how we add peer nodes, and so on. There is information on the pricing, and there's other links to documentation and other things that you'd find useful. What we are going to do here, we're just going to create a network. And you have two choices. You have a Hyperledger Fabric 1.2 network or an Ethereum network, which is coming soon. So we're going to create a Hyperledger Fabric network. There is a starter edition and a standard edition. If you click on info, you're going to see a link where you can look at the different pricing options for managed blockchain. We'll create a starter edition, and we're going to give this network a name. We're going to call it NGO for our non-profit organization. You can enter an optional description if you like. And what we see here on this page is a voting policy. Again, if you click on info, you'll see some information on the right-hand side. Essentially, what the voting policy is, it's the first pass at wrapping a governance policy around the blockchain network. Let's imagine you have 5 banks in your blockchain network, and Bank 6 wants to join the network. Well, who gets to decide whether Bank 6 should join the network? What we can do is we can use a voting policy so that other members of the network, other banks already in the network, get to vote on whether they think Bank 6 should be allowed to join the network or not. So this is really the first step in putting a governance policy around the blockchain network. You can specify that more than 50% of the members of the network need to vote on a proposal before that proposal is accepted. So if you had 5 banks in a network, you would need 3 of those to vote yes before Bank 6 would be able to join. You also get to use the voting policy when a member wants to be removed from the network. A member could be quite an important part of a blockchain network, and you may not want that member to be removed. So again, the members in the network can vote as to whether it's a good idea for that member to leave the network or not. All right, so we click the next steps. Now, whenever you create a blockchain network, a Fabric network, you need to create members. Members are also known as organizations in Hyperledger Fabric, and these usually map to a real-world organization or company or some other type of legal entity. So what we would do here is we would enter the name of the member. This could be the name of a bank, the name of some other company. You would enter the member's name here. This is just for the first member. Obviously, there would be other members in this network, and you can put an optional description over here. Now, when we create the member, we also create a certificate authority for that member. Each member has its own root certificate authority, and this is because Hyperledger Fabric is a permissioned network. It's a private permission network, blockchain network. This means we need to know the identity of every person or every entity that is operating in that network. So the first thing we do is we generate a certificate authority for each of the members, and then that certificate authority is used to generate the identities for all of the other parties belonging to that member that interact with the network. Now, it's very important that you do not forget this admin username and password. So whatever you type in here, make sure you make a copy of it, because you will need it later to generate, to enroll the admin identity. What's going to happen now when I click on the create button is that the certificate authority will be bootstrapped with this admin username and password. And you will need that the first time that you interact with the network. So I'm showing my password here. That's the password I'm using. I suggest you use something different. But definitely write that down, take a screenshot, don't lose it. All right, we click on the next button, and here we just get to review the network options and to create the network and member. Now this takes roughly 15 minutes. I'm not going to do that now because we don't want to wait here for 15 minutes twiddling our thumbs. So I have created a network earlier, and we're going to use that network. All right, so in your case, you would just click Create Network and Member. What I'm going to do is I'm going to go to my member that I already created, look at what we have here. So we have a network with a network ID. The network ID starts with N-. It's always easy to identify the IDs in Managed Blockchain. N- means it's a network ID. If I click on the network here, we're going to see details of this network. And we can also look at the members of this network. Here is the member that I created. The member also has a unique ID starting with M-. And if I click on the member, I'm going to see a peer node for this member. The peer node is where the ledger sits. I'll explain this a little bit later. And the peer node starts with ND-. You can create additional peer nodes, or you can create your first peer node for a member simply by clicking Create Peer Node and selecting the instance type that you want and the availability zone that you want it to be in. Normally, if you are running a production Hyperledger Fabric network, you would have 2 peer nodes in 2 different availability zones for each member, so that we have 2 copies of the ledger. Okay, so we have our blockchain network and we have our peer node. Let's switch back to the README file. Step 1 said create the network, and step 2 says create the Fabric peer node. So we have done both of those steps. What we're going to do now is create a Fabric client node. So I'm going to create this, and then I'm going to explain to you what it is. All right, so I'll create it first. It takes 5 minutes or so to create, and it will use CloudFormation to create this Fabric client node. And once we have the client node, I'll explain to you how we use it and how it connects to our Amazon Managed Blockchain network. So the first thing we're going to do is I need a couple of export variables. I need a network ID and a network name so that I can use them in the script that I run a little bit lower down. So I'm going to simply just copy those 3 lines over there, and I'm going to come into my Cloud9 command line once again. I'm going to paste those in. Obviously, they're going to fail because there's no network ID there. What I need to do is just enter in the network ID for my network. And I can get this from my console. So as I mentioned to you before, if you go into the console, you can see that the network has an ID over here. I'm going to simply copy that, Control-C, and I'm going to Control-V and paste it here and hit Enter. And I'm going to do the same for my network name. My network name is called NGO. I'm just going to type that in. And then if I go back to my README file here, I'm going to use those variables to run an AWS Managed Blockchain Get Network command. Okay, and that network command is going to export the VPC endpoint for my blockchain network. Again, I'll explain this in a few minutes. Now, finally, what I'm going to do is I'm going to run a shell script, and the shell script is going to create a CloudFormation stack for me. So let's get that started. It's going to come up with an error saying key pair not found. That's expected. I expect to see that error. I'm trying to create a key pair, and I do not want to overwrite an existing key pair that you might have that might be important for you. So that's why we check if the key pair exists before we continue. Now that is creating a CloudFormation stack. I can come into CloudFormation and I can see that my new stack is being created over here. You can see it's creating a VPC, an internet gateway, and a few other things. We will come back to this in a couple of minutes. So let's give that a few minutes to continue. What I'm going to do is switch to the PowerPoint and explain a little bit more about the Hyperledger Fabric components that we are creating here. Right, so in this webinar, we are building a Fabric network that looks like this. You can see that there are two parts to this diagram over here. The top part is a Fabric network managed by Amazon Managed Blockchain. Now, the Amazon Managed Blockchain, a Fabric network consists of three main components. Firstly, an ordering service. The ordering service in Hyperledger Fabric is part of the consensus mechanism, and it is responsible for taking in transactions and ordering those in a specific order, and then grouping those into blocks. And once the blocks have been created by the ordering service, they are then distributed out to the peer nodes. The Fabric certificate authority we discussed a little bit earlier. Each member in the network or each organization in the network has its own certificate authority, and the CA is responsible for generating all of the identities used by that member. This allows us within Hyperledger Fabric to always be able to identify which member carried out a certain action. Whether that action is invoking a transaction or whether it's doing some type of administration in the network, we can always identify who did what, because every action is signed by a certificate generated by that CA. Finally, we have the peer node. Each member will have one or more peer nodes, and the peer node stores the ledger. The ledger is made up of two parts. It's made up of a blockchain. So the blocks in the network are chained together using hash numbers, and they are stored on the peer node. The peer node also contains a key value store. It's a database that houses the state, the world state as it's called, of the data in that network. And each peer node will have its own copy of the ledger. Now, all of that is fully managed for you by Amazon Managed Blockchain. You will not even see these components in your account. They are managed in an Amazon Managed Blockchain account and network. And what you have in your account is what we see at the bottom of this diagram. For example, if you are member A, you will have your own VPC, your own virtual private cloud. And inside of that VPC, you will have a VPC endpoint, which points to the components managed by Amazon Managed Blockchain. This VPC endpoint uses Amazon VPC private link, which means that all the traffic over this network connection goes via a private connection on the Amazon backbone. It does not go over the public internet, and that traffic is all protected and encrypted. And in your account, you will have a Fabric client node. Fabric client node is very simply an EC2 instance that runs the Fabric tools command line interface, and you will use that to interact with your Fabric network. So from that Fabric client node, you can connect via the VPC endpoint to the peer node, the certificate authority, and the ordering service inside the Amazon Managed Blockchain network. A more complicated network would look something like this. So if you had multiple members in your network, for example, a couple of banks, a recognized market operator, which could be an arbitrator, for example, an exchange like Singapore Exchange or Hong Kong Exchange. You may also have a central bank in your network, such as the Monetary Authority of Singapore or Hong Kong Monetary Authority. These would all be different members in your network. Each of those members would have their own certificate authority, and they would have their own peer nodes. Inside each of their AWS accounts, they would be running their own Fabric client nodes and connecting to their own members and able to administer and manage the network and also invoke transactions and query the ledgers from their own client nodes. All right, so I think I mentioned this a little bit earlier. The typical layered architecture that we're going to be building here, if we start from the right-hand side in this diagram, we build firstly an Amazon Managed Blockchain Fabric network, which is what we're doing now. And then what we'll do on top of that is we will run a RESTful API that connects to the blockchain network through an SDK. Then we will run an application, a user interface application, a web application that connects to the RESTful API and therefore interacts with the Fabric network. So that's the typical layered architecture that we would use when interacting with a blockchain network. All right, so I've been talking enough now. Let's get back to building. Right, my CloudFormation stack has completed. All my resources are being created, and I've output some useful information in the Outputs tab. You'll see in the Outputs tab, there is a URL for my EC2 instance. This is my Fabric client node, right? This is the URL for my Fabric client node, the DNS endpoint. And there's a couple of other things in here that we'll use as we go along. Let's switch back to our README file and get on to the next steps. Step 4. Right, so for step 4, I need to be on the Fabric client node. Now, to get to the Fabric client node, I will SSH into that Fabric client node. This should be familiar for anyone who's used EC2 before. I'm just going to clear this page so we can see it at the top. I'm going to SSH into that. So what we're going to do is we're going to go back to our Cloud9 command line. I'm going to SSH into the Fabric client node. Now, to do an SSH, I need my PEM file. Now, I stored the PEM file earlier when I ran that script that created the CloudFormation template. So it is in the home directory. And the other thing that I need the DNS for my Fabric client node, which I have output as one of the outputs in the CloudFormation template. So if you look at the EC2 URL key, you'll find the value here is the DNS that we need for the Fabric client node. So we SSH into that. You might get a warning that says, are you sure you want to connect? You just say yes. And what we're going to do now is we're going to clone the repository, the same repository that we cloned on our Cloud9 instance. All right, so we clone that. And now we need to edit our exports file. So what happens here is that as we go through this README file here, we're going to be using a number of different environment variables. And instead of having to copy and paste those every time we need them, I've put all of them into this export file over here. So what we need to do is we need to edit this file. We need to tell it which Fabric network we are using, and then it will generate a whole collection of export variables for us. So this saves us a lot of effort later. It's just a little bit of a pain now because we have to edit the file. I'm using VI to do the edit. All right, so what we need to do is these environment variables that appear at the top of the page here, we need to update these. So to give an example, the network ID, I need to change that to the network ID that I can find in the Amazon Managed Blockchain console. So if I go into the console and I select my network and I click on details, you'll find the network ID here. It starts with N-. So I simply just Control-C to copy that, and I just paste it in over here. I need to do the same for the member ID. What I'm doing here in VI, I'm just hitting Shift-A to take me to the end of the line and put me into insert mode. And then I am going into the console, selecting my member ID, which starts with M-, and I am pasting it in here. Now here is where I need my admin username and password. This is the same admin username and password you entered when you created your Fabric network. It's the one I told you to please take a photograph of or to write down somewhere and not forget. You need it here. So we type all of this in. This was the password that I used a little bit earlier. And finally, I just need the name of my network and the name of my member. Those are quite easy to remember in this case. And one last thing I just need to do. This may be done before you by the time you get to this. I just need to make sure I'm in my home directory before I do that install. All right, so I escape that, Shift-ZZ. Come back to my repository here, and the next command is to source that file. When I source the file, it's going to update my CLI on my Fabric client nodes that I have my managed blockchain CLI available. And it's going to export all of these useful variables down here. So let's take an example. If we look at the ordering service endpoint here, this is the endpoint of the ordering service. You can see the same information if you go into your console and you look under details for your network, you will see the same endpoint mentioned over here. So these export variables just save us having to copy and paste this information. Just going to clear that page. Now, one other thing we do is we also export a peer export file. Let me just show you what that looks like. The peer export file has a collection of environment variables that we use when we interact with Hyperledger Fabric. So, for example, it has the endpoint for the peer and the endpoint for the orderer. It also has the name of the channel that we are going to create. And it has the name of some Chaincode or smart contract that we're going to install. Typically, anyone using Hyperledger Fabric would use environment variables like this to interact with the Fabric network. So I, again, just create those in a file that we can source. All right, so we source those, and they are now available in our session. If you exit your session and you come back into that SSH session, you will need to source these two files again. You won't need to re-edit the Fabric exports. It should already be edited. You just need to source it. All right, now we need to get the latest version of the managed blockchain PEM file. This is the file that you will use when you communicate with managed blockchain. All communication with managed blockchain is over TLS. So you will need the TLS certificates when you interact with managed blockchain. Finally, we are at the stage where we are going to execute our first command against Hyperledger Fabric. This command here, Fabric CA client enroll, is going to enroll an identity with the Hyperledger Fabric CA, the certificate authority. Now, what this actually does, in Hyperledger Fabric CA, there are really two main commands. There's a register command, which allows you to register new identities. And then there's an enroll command, which doesn't really do enrollment. What it does is it actually downloads the keys and certificates that you are going to need to interact with Hyperledger Fabric as that particular user. So what it does is it creates a directory, MSP directory, as you can see on the end here, admin MSP. And into this directory, it will download the keys and certificates that allow us to act on the Hyperledger Fabric network as this user. And the user that we are acting at as is the administration user. So I'm going to simply copy that, paste that into my Cloud9 over here. And what is that done? It's stored client certificate, it's stored root CA certificate, and it's stored them in this directory that you can see here. All right, so now you'll have some PEM files and other things in there. We just need to do some final copying because not everything is in the right directory. And now we're ready to go. All right, so we move on to step 5. In step 5, we update the config TX channel configuration. Now, what does this mean? All transactions in Hyperledger Fabric take place on channels. You can have multiple members connecting to different channels in Hyperledger Fabric networks, and the members that have access to those channels are able to see the transactions and query the ledgers related to those particular channels. Now, to create a channel, though, you need to use a channel profile or a channel configuration. And these channel profiles are stored in a file called config.tx.yaml. So what we're going to do is, let's take a quick look at this file so you can see what it looks like. I need the member ID when I edit this file, so I'm just outputting it here so that I have it in my command line, so I don't need to go to the console to copy that. I'm going to VI this file here. Before I VI it, I'm just going to copy that into my clipboard. All right, so there is a file called config.tx.yaml. And this, to some extent, describes what my Fabric network looks like. I'm going to just go to the bottom of this file. At the bottom of this file, I have a section called profiles, and inside profiles, I have something called OneOrg channel. OneOrg channel has a single organization called org1, and I'm going to create a channel that allows org1 to transact on a Hyperledger Fabric network. Now, this is a very simple Hyperledger Fabric channel. It only has one organization. That's not really a typical structure. Typically, you would have multiple organizations sharing the same channel. But since this is a demonstration and we're just using one organization, what we're going to do is put the member ID for that member, for that organization, under org1. So I'm associating org1 with my member. When I say member, what do I mean? I mean this member over here that I have in my network. Here is the member ID. I'm now associating this member with organization 1 in this config.txt file. And from this file, I'm going to generate a channel configuration. All right, so that is the only change I need to make to that file. Hit escape and then Shift-ZZ to save that. And now I'm going to execute my first command. This command uses a utility called config.txtgen, and it is going to generate a channel configuration file for me. The channel configuration file is used to create the Fabric channel, and it becomes the Genesis block on the channel. For those of you familiar with blockchain, all blockchain networks are initiated with a Genesis block. In the case of Hyperledger Fabric, each channel that is created is initiated or initialized with block 0. Block 0 is the Genesis block for that channel. And we create the config file for that Genesis block using this utility here. So what I'm going to do is I'm going to exec into my CLI container, which is running as a Docker container on my Fabric client node. I can actually show you that. If you're on the Fabric client node and you do a Docker PS, you'll see that there is one container running, which is the CLI container. And it's running Fabric tools. So this is the Fabric tools command line. So I exec into that container and I execute this command here. I simply just have to copy that. So we'll copy that and we paste it in here. All right, so that is written the channel configuration, and I can have a look at that now. So in my home directory, if I do an ls, I should have a file called mychannel.pb. All right, so this is my channel configuration file that I've just generated using that utility. And what I'm going to do in step 6 is I'm going to use that PB file, that channel configuration file, to create a channel in Hyperledger Fabric. So what we do to do that is we use this, we exec into the CLI container again, and we use the peer channel create command. Peer is a binary that's deployed on the CLI, so we have access to the peer binary, and we can use the peer channel create command to create a channel using that PB file that we generated in step 5. So all I need to do here, I just copy all of this, and I come in here and I paste that in. What it's doing is it's creating the channel, and it's waiting until block 0 is ready. You can see the last statement we got here. It says received block 0. So the channel has been created. The channel has been initialized with the Genesis block, and we have now pulled block 0 from the channel, and we have downloaded it. The peer channel create command actually returned block 0 to us. Now, it's possible that your peer channel create command could time out. We have put quite a long timeout on it. You can see the timeout here is quite long, so it shouldn't happen. If it does happen, there's no problem. You can actually use this command over here to fetch the Genesis block from the channel at any point in time. You can do it now, you can do it in 6 months' time. You will always get back block 0 when you do a peer channel fetch oldest, which is what we're doing here. So if you do get a timeout, you can just pull the Genesis block using that command. And this ls command is going to show us the Genesis block, mychannel.block, sitting in that directory. All right, so I've created a channel. Now the channel is isolated. I need to actually join my peer nodes to the channel. Once my peer node is joined to the channel, then it will start to receive any blocks that are on that channel. In this case, there's only one block, which is block 0, but I will join my peer node. So let me clear the screen again so that the commands appear at the top. I'm going to paste in that command there, which does a peer channel join. It's joining my peer node to the channel that I just created. That's executed successfully. And I'm now going to install some test chain code on my peer node. So this is a peer chain code install command. And what this is doing, it's deploying some chain code from the Fabric samples repository. So the Fabric samples repository is already on the Fabric client node. We install it as when we set up the Fabric client node. And what we're going to do is we're going to install some Fabric samples chain code just to test that my peer node and my channel is working correctly. All right, so this does a peer chain code install. It installs the chain code listed in the environment variables, which is really just the sample chain code from Fabric samples. So let's install that. What does install do? It copies the chain code from my Fabric client node. It copies it to my peer node. So that's what is happening during the install. Now, the big statement that we need to execute is the instantiate statement. Peer channel instantiate is a binding operation. It binds the chain code to the channel. Now, when we say binding chain code to channel, what this actually results in, it results in a ledger. Okay, so when you bind chain code to a channel, for each peer node that is part of that channel, they will then have a copy of the ledger, a ledger for that chain code channel combination. And behind the scenes on each peer node that has installed that chain code and is part of that channel, each peer node will execute the chain code inside a private Docker container. So in this case, I'm connecting to my peer node and I'm instantiating the chain code on the channel. Behind the scenes, this will create a Docker container for me, and it will deploy my chain code into that Docker container. So that's why this command typically takes 30 seconds or so to run, maybe a bit less, because it is behind the scenes building a private Docker container, putting my chain code into that Docker container, and then getting ready to execute my Docker container. What it does do after it's created the Docker container is it calls the init function on my chain code. So it calls one of the functions on the chain code just to initialize the ledger. Okay, now what we can do, because we have the chain code bound to the channel and we have the chain code installed on the peer node, we can actually do a peer chain code query, and we can query that chain code on our peer node. And we're going to see a value of 100. What has this done? It's very simply just queried account A in the sample chain code. And if we look a little bit further above, when we initialized the chain code over here, we initialized it with two accounts, account A with a balance of 100 and account B with a balance of 200. We've now just queried account A and we received a value of 100 back. What we'll do next, we'll simply invoke a transaction that transfers $10 from account A to account B. So let's run that. And then I'm just going to hit the up arrow, go back to my query command, run the query again, and the result shows me that I have a value of 90, a balance of 90. So the $10 has been transferred from one account to the other, and my balance has been updated. Now, this is the end of part one. What we have done here in part one, we have created a channel, we've installed some chain code, we've instantiated that sample chain code, and we've invoked a transaction to test that it works. We're going to move on to part two. In part two, we actually deploy the chain code or the smart contract for our non-profit application. We're actually going to be following the same steps that we've just gone through. But before I do that, I want to explain to you a little bit more about chain code. So let's have a look at this section in the deck here. Hyperledger Fabric chain code. In Hyperledger Fabric, we can write chain code in one of three languages: Golang, Node.js, or Java. Notice that these are all traditional programming languages. This is a little bit different to a blockchain platform such as Ethereum, which uses its own programming language known as Solidity. Solidity is a deterministic programming language, whereas these three languages here are not. If you're interested, you can have a look on the internet and see what I mean by deterministic. And the reasons that Ethereum uses determinism is it's a little bit complex to explain now, but you're welcome to go and have a look and to see why that is the case. Now, Chaincode is a smart contract in Hyperledger Fabric where the code is executed on the network. It's actually executed on the peer node. Right? The Chaincode sits on the peer node and it can query and update the ledger. And as I mentioned before, the Chaincode executes within a private Docker container. Each new version of the Chaincode will result in a new Docker container, and each different Chaincode that you deploy will result in a different Docker container. So all Chaincode is executing in private Docker containers on the peer node. And the Chaincode has two main operations: an init operation, which initializes the Chaincode, and an invoke, which allows you to invoke methods and transactions on the Chaincode. Now let's actually have a look at some Chaincode very quickly. So we're going to go into our GitHub repository and we're going to have a look at the Chaincode in the file ngo.js. All right, so if we go into our repository here, we go nonprofit, we go into ngo Chaincode, we go src for source. Here is the file called ngo.js. This is the actual smart contract that we are running within this Hyperledger Fabric network. And we're going to look at line 400 to show you the implementation of the Chaincode interface, and line 455 to show you how to add a new donor to the ledger. A donor is the person who is donating money to this nonprofit organization. Now, if we scroll down to line 400, this is where the actual Chaincode interface begins. Here is my Chaincode class. And these are the two functions that I mentioned earlier. On line 407, we have the init function. And on line 418, we have the invoke function. So the init function is executed every time you instantiate or upgrade Chaincode. And what it's meant to do is initialize the ledger. But you need to be very, very careful here. It's called when you upgrade the Chaincode as well. So let's imagine you instantiate your Chaincode, right? Version 1 of your Chaincode has been instantiated, and in this init function, you initialize your ledger. If you come along with version 2 of your Chaincode and you upgrade it, it will again call the init function. You want to make sure that you do not overwrite any of the state in your ledger, because if you do, you will lose that information. You will not lose the blocks. All the blocks will still be created and still be visible and still be immutable as ever in the blockchain part. But the actual world state key value store, you will be overwriting the state in that. So never initialize the state in the init function. If you want to initialize some state, then do that in another function and call that only once when you do the instantiate. The invoke function is a simple function. You really pass it two pieces of information. You pass it the name of the method that you want to execute, and you pass it the arguments to that method. And now to give an example, what happens if we want to create a donor, a new donor in this network, we want to call this method here, which is create donor. We are going to pass two arguments to the invoke function. We're going to pass the name of the method, which is create donor, and we're going to pass the arguments, which is simply a piece of JSON, which contains the donor that we want to add to the network. So if we call this function, it's going to do two things. It's going to check if the donor already exists. To check that the donor exists, we simply do a get state against the world state database, the key value store in the ledger, passing the key or the donor ID. If that donor exists, then we just throw an error message. If the donor does not exist, then we do a put state to add that state, to add that new donor to the key value store. So that's very simply all the create donor is doing. That's an example of a method in the chain code. All right, I'm going to skip the transaction flow in the interest of time. The only thing I want to mention here is it's slightly different to a database transaction in that transactions do not get committed immediately to the ledger. They get simulated against a peer node. And what we do is we take all the information that would be written and read from the world state database, and we digitally sign all of that, pass it to the ordering component. The ordering component groups it into blocks, and then we send those blocks back to all the peer nodes. You can find more information about this on the Hyperledger Fabric documentation. In the documentation, just note that whenever you insert or update anything in a Hyperledger Fabric blockchain, it's going to take roughly 2 seconds. Blocks are created by default every 2 seconds. That is configurable. You can change that. But it's not going to be immediate like it would be in a relational database. All right, let's get back to deploying the chain code. So I'm going to go back to the page that I was on, the README page in my chain code, part number 2. Right, part number 2 is where I deploy the non-profit chain code. Now the prerequisites you won't need to do here because you would have done them already. You'd only need to do this if you exit your SSH session on your Fabric client node and need to come back in. Otherwise, let's get down to step number 1 here. Now, I did show you earlier that, if I go back here, that, let me clear this page. If I do a Docker PS, I'm seeing that I'm running a CLI container. I can inspect that CLI container, and it's going to show me a whole lot of useful information. The one thing I want to point out to you now is that it has a mounts section. And what the mounts section is doing is it's mounting directories from my Fabric client node into my Docker container. All right, so for example, here, I have a directory on my Fabric client node called home EC2 Fabric samples chaincode. And this is where the Fabric samples chaincode has been installed. And I'm mapping that to opt-go path source github.com inside the Docker container. Now, what I want to do is I want to make my chain code available to Hyperledger Fabric. So I need to get my chain code into this directory. So I'm going to copy it into this home directory here, the source directory, and that will make it available via this mount in the Docker container directory here. All right, so that is what I'm trying to explain there in that section. As you can see here, what we do is we copy the chain code from the repository into the Fabric samples directory, which will then make it available in my CLI container. Just clear that page again. Right, and there I do the copy. That's copied my chain code. I'm now going to install the chain code on my peer, exactly the same command as we executed before, peer chain code install. The only difference now is that the name of my chain code is different. It's now called NGO. I'm passing a -L argument and telling the chain code install statement that my chain code is written in Node.js. The default is Golang. So I'm telling the install that I'm using Node.js chain code over here. This becomes quite important when you instantiate the chain code. We want to make sure that Fabric is instantiating a Node.js container to run my chain code. And then I'm passing the path where it can find my chain code. And this is the same as what is mapped to this mount directory here. All right, so this does an install. As I mentioned before, install simply copies the chain code to a directory on the peer node. And then I do the instantiate. Instantiate is a binding operation. It's now going to bind this NGO chain code to my channel. And then behind the scenes, it's creating a Docker container. It's then installing my chain code in that Docker container, and it's calling the init method on my chain code. So while all that happens, I'm going to prepare myself to query the chain code. I'm going to execute peer chain code query, and I'm going to call this method, query all donors. And I get back an empty array, which is what I expect because there is no information in this blockchain network at this point. So what we're going to do now is we're going to invoke a transaction on this particular chain code. The transaction we're invoking is to invoke the create donor method. This is the method we just looked at 2 minutes ago. And here is the JSON string that I'm now going to pass to this. I'm going to create a donor called Edge with an email address over here and a particular registered date. I'm going to copy both of these commands. So we're going to create 2 donors. I just paste that in here. All right, and both of those have been executed. Now what I'm going to do, I'm just going to hit the up arrow a couple of times, go back to my query statement, hit enter, and now you can see that I have 2 donors. Now these donors are sitting on my peer node. If I could look at the blocks on my peer node, we would have an additional block that has now been added, and that block would contain these transactions. There may be 1 or 2 blocks, depending on how the orderer service grouped the transactions into the blocks. And my key value store, my world state database on my peer node, has been updated with these 2 donors. And the query all donors method has simply queried that world state and returned the donors to me. So that is what we're seeing there. So that is us operating at the chain code level, at the Hyperledger Fabric level. So what we have done so far, we've installed our chain code, our non-profit chain code. We have instantiated that by binding it to the channel. We have queried the chain code and invoked a transaction to add some donors onto via the chain code onto that channel. So if we had other peer nodes in the network, all of those peer nodes would have received a copy of the blocks that have these donors. All right, so what we will do now is we will move on to part 3, where we're going to deploy a RESTful API server. Now, this will only take us a couple of minutes. But before I do that, let me just explain to you how the Hyperledger Fabric SDK works. All right, Hyperledger Fabric provides SDKs in Node.js and Java. SDKs are software development kits that you can use to interact with a Hyperledger Fabric network. So as you can see so far, I've been interacting with the Hyperledger Fabric network through the command line. Right, I enrolled a user with the network. I have installed some Chaincode. I've instantiated Chaincode. I've invoked transactions. And all of that I've done via the command line. You can do all of those things programmatically using the SDK. The SDK allows you to write an application that connects to the Fabric blockchain network. And you can register and enroll users, create join channels, install, instantiate Chaincode. You can invoke transactions and query the ledger. All of the things you've seen me doing on the command line, you can do that in an application as well. Hyperledger Fabric will soon release SDKs for other languages, Golang, Python, even a REST SDK, but at the moment we are limited to Node.js and Java. So what I have done is I have developed a REST API using Node.js and Express, and that REST API is using the Fabric SDK to connect to the Fabric network, and it is allowing us to invoke transactions and query the ledger via a REST API. So let's take a quick look at that in the GitHub repository. So if I go here to nonprofit blockchain, here is my REST API. I am going to look at app.js line 203. All right, so for anyone familiar with a typical Node.js Express application, that's all this is. The only difference really is that inside of this application, we're using the Fabric SDK. You can see that we're using some Fabric libraries in here, and this is allowing this Express application to connect to the Fabric network on the back end. And if we go to line 203 here, what I have is I have a post method on the donor's resource, all right? So here I am posting a donor. Anyone familiar with the REST API, you'll know that this means we're creating a new donor, we're adding a new donor. And this is a very simple method over here. I'm simply getting my list of arguments from the request body, which is just going to be the JSON string that I'll be using. And the function that I want to call on my blockchain network is called create donor. You might recall that we looked at create donor inside the Chaincode a little bit earlier. So I want to call that method from my REST API. So what I do is I call this function called invoke Chaincode. We're going to take a quick look at that. It's a little bit complicated, so you can have a look at it at your leisure. I just want to point out a couple of things here. What this method is doing, this invoke Chaincode method, I'm telling this method that I want to invoke the Chaincode called create donor, and I want to pass in this JSON string. So what it does down here, it sends a transaction proposal to the peer nodes. We very quickly went through the transaction flow on a Hyperledger Fabric network before, but the first step in a transaction flow in Hyperledger Fabric is to send a transaction proposal to a peer node or to multiple peer nodes. So what you would typically do is you would send a transaction proposal to 2, 3, 4 different peer nodes, and those peer nodes are going to execute the transaction, but they're not actually going to update anything, right? So they will not update the world state. They will not update the ledger in any way. They will simulate the transaction, right? They simulate it. And what they do is they package all of the information they read and all of the information that they updated into a single package as a read-write set, and then they digitally sign that package with their own private key. They then submit this package back to the client node. So the client application that invoked the transaction receives back 1, 2, 3, or 4 packages from different peer nodes, all of them signed by those peer nodes, so we know which peer node signed the proposal. And inside each proposal is a read-write set, which is what Fabric would update if it had to really execute the transaction. So at this point, nothing has been updated, it's just been simulated. And then the invoke transaction has a look at these proposals, make sure that they're all good, make sure that they're valid, and once it's happy with that, it wraps the whole set of proposals together in one big package, and it submits that to the orderer. So this is the point where the transaction is sent to the orderer, and the orderer would be receiving transactions from multiple peer nodes all at the same time. And it would be ordering those and grouping those into blocks. Once the blocks had been created, the orderer would be sending those blocks out to the peer nodes. Only when the peer node gets the block back does the peer node loop through the transactions in the block and apply those transactions to the ledger. So at that point, each transaction will get written to the blockchain. Sorry, each block would get written to the blockchain, and each transaction would be then applied to the key value store in turn, in order. So only at that point is the ledger actually updated. And as I mentioned before, that takes roughly 2 seconds, depending on how often your Fabric network is creating blocks. So those are the only 2 things that I wanted to have a look at there. What we can do now is go back to the README for the REST API. Okay, so that's enough talking. Let's wrap up that before we get onto the summary. All right, so I'm going to run a RESTful API, and I'm going to run the RESTful API on my Fabric client node so that it can communicate with the Fabric network. All right, as I mentioned before, you might recall that diagram I showed you a little bit earlier. In fact, just to make it clear to everybody, I'm just going to go back to that. So on this diagram that I showed you earlier, which is here, we have a Fabric network managed by Amazon Managed Blockchain, and down here in your account, you have a Fabric client node. That client node can communicate with the Fabric network via a private link connection. All right, so we're going to run the REST API on the Fabric client node so that it can communicate via the VPC endpoint with our Fabric network. All right, so that's what we'll be doing here. So we don't need to worry about the prerequisites. We're already in the Fabric client node, but what we do need is we need Node.js on our Fabric client node so that we can run the REST API. So again, let me clear the screen. You can just simply copy these commands. We're going to install Node Version Manager here. Probably not absolutely necessary, but I always like to use it so I can switch between different versions of Node. And we're going to use Node version 8. All right, so LTS Carbon, it's a long-term supported version. Node version 8, we're going to install that. There's a package missing, so I'll need to install that as well. Oops-a-daisy. Install the package. And finally, we do an npm install. So anyone familiar with Node.js, we always do this. In Node.js, you put all your dependencies into a package.json, and then you simply run npm install, and it will download all of those packages using the Node Package Manager and install them into the Node modules directory. And once all of that has been generated, we are ready to run our REST API. Now, question. How does the REST API connect to the Fabric network? I mentioned that it uses the private link connection to connect to the network, but what it's actually using inside of Node.js, it's using something called a connection profile. A connection profile is a YAML file which has the details of all of the endpoints that the application needs to connect to. Now, it's a bit of a pain actually to create these YAML files. What I've done is I generate the YAML file here automatically using all of those environment variables that we set up earlier. So you just simply need to copy and paste those few lines over there, paste them in, hit enter, and that is going to show us what the connection profile file looks like. So this is the YAML file that you would have had to create manually. You could have copied all of these endpoints here from the Managed Blockchain console. But because we already have them in environment variables, I simply generated them for us. So we have the endpoints for the orderer, for the peer, and for the CA. That means our REST API, which is using the Fabric SDK, can now connect to the orderer, the peer, and the CA using all the information in this connection profile here. Now, the only other file used by app.js is a config file called config.json. It has the username and password for the admin user that I need to use. We don't need to update this because it's already using the correct password, but if you were using a different username and password, you'd want to VI that file and just update those. Okay, so let's run this application. All right, so my REST API server is running. And what I want to do now is I want to execute some commands against that. But I'm not going to paste them in here because there's a whole lot of comments and other log entries that appear on this page. So I'm going to just open another window, another terminal window inside of Cloud9. I'm going to SSH in using the same PEM file we had before. And I'm going to use the DNS from my CloudFormation. Paste that in there. I'm now in my Fabric client node on 2 different sessions. Okay, so here is all my log entries appearing, and here is another session over here that I can use. Now, what I'm going to do is I'm going to register or enroll a user. So in this case, this is calling a resource, a REST resource called users, and it's going to create a new user called Michael. Behind the scenes, what this is going to do, it's going to call the Fabric CA and the Fabric Certificate Authority. It's going to register a new user and download the certificates and keys for that user. Right, so let's paste that in here. Tells me that it's been successful. And if you look in here, there's a whole collection of log entries telling me that I've just posted a new user called Michael. And if you're interested, you can take a look and see what actually happened behind the scenes there. Now I'm going to post a donor. This is calling the donors resource on the REST API, and it's doing exactly the same thing as what I did when I demonstrated the Chaincode. It's calling the create donor function. You might remember that we actually looked at this code in the REST API, and we saw that it calls the create donor Chaincode. So I'm going to do exactly the same as I did before by creating a donor. This time, though, I'm using the REST API to do it instead of operating at the Fabric layer. All right, so I get back a transaction ID, and if you look in the log file over here, you'll see there was a post on donor, and you can look at there's all the arguments that were passed and so on. All right, so you can take a look at that. All right, let's get all the donors. Here I'm doing a get on the donors resource. And you can see now that I have 3 donors. I have Brendel over here, I have Edge over here, and I have Edge2. Edge2 was the donor that I created via my REST API, and the other 2 were the donors that I created via the Chaincode. And you can see they both look the same. So inside my ledger now, I now have 3 donors. And I can load all of the workshop test data. So I do have a script that loads a whole lot of test data into this network. And it uses the REST API to do that. So let me just edit that very quickly by copying and pasting those commands in here. The only thing I want to update here is I need to tell this script what the endpoint is of the REST API. Okay, and what I've done a little bit earlier when I created the CloudFormation template is I created a load balancer, an ELB DNS, and I pointed this to where I knew the REST API would be running. Right? I know where the REST API is. I know it's running on the Fabric client node, and I know what port it's running on. So I created an ELB that would be pointing to that Fabric client node and port. And the health checks for that have probably been failing for quite a while, but they would have started succeeding once my Fabric client node started running. So I simply just need to put the endpoint in here, and then I can Shift-Z and save that file. And then what I'm going to do is I'm just going to run that script. What that script does, it creates a whole collection of different test data in that network. So it will create some non-profit organizations, it'll create some more donors, it will create some donations, and a whole bunch of useful information. After it creates them, you can see the transaction IDs there. That is the records being created in the blockchain network. And then I query them. So you can see where I query, for example, all donors. You can see the list of donors coming out there. All right, so we'll let that script run in the background. It should only take a few seconds. All right, now what we're going to do, we're going to move on to part 4. Part 4 is the final part that we will be looking at in today's webinar. In part 4, we will deploy the user interface application. The user interface application is a Node.js Angular application. And we're going to run this application on our Cloud9 instance. From Cloud9, the Node.js application will connect to the REST API using the REST API endpoint. Very straightforward. And then the REST API, as we've discussed, will connect to the Fabric network via the connection profile that it had. So what we're going to do is, on our Cloud9 instance over here, we're going to follow very similar steps to what we did in step 3. We're going to install Node. Again, it's the same version of Node that we were using for the REST API. So let me clear the screen here. I need to be in Cloud9, okay? So I need to open up a new terminal window. When I open up a new terminal window, I will be automatically in Cloud9. And I just need to install Node version 8. Again, I'm using Node Version Manager, so the same as what I did before. I also need to install my dependencies. Again, oops, sorry. Let me just make sure that executes first. NVM use LTS carbon before I paste in the next statement. I will be installing my Node package dependencies. This is a normal standard Node.js application. And once that's finished, I need to make one very simple change to this application to point it to my REST API. So I will edit this environment file here once this install is finished, and I will point it to my RESTful API endpoint. Okay, so that's done. I now VI the file. And there are two lines that I need to edit. There's an API URL and there's a socket URL. The application does use WebSockets. They both point to the same endpoint. And the endpoint that I'm looking for here is the same ELB endpoint that I used before. It's the one that you can find in the CloudFormation stack under the ELB DNS key. All right, now very important here for the API URL. Right, we had a reconnection there. For the API URL, I'm just going to hit the backspace. I'm going to paste that in, and I need to make sure that I have the trailing slash. For the API URL, for the socket URL, there is no trailing slash required. Okay, so very important that you make sure that that is in there. All right, now I escape that, Shift ZZ again. Back to my repository. Step 4, I start the application. And this is an Angular application, so what's happening is it's compiling and building behind the scenes. And in a few seconds, this application will be up and running. Now, once this application is running, you can see the information in here. We're going to preview the application directly via Cloud9. So Cloud9 does have a preview function. If you run an application on a Cloud9 command line, you can preview that. As long as it's running on port 8080, and my application is running on port 8080. So I will preview that, and we'll actually interact with the application via that interface. So it looks like it's running. So to get to the preview button, I need to minimize this command line again. So I just click on this button over here, which will minimize my command line and allows me to see the rest of the Cloud9 page. And I can just click preview running application. And this is going to pop it up in a little box in the bottom right-hand corner here, which isn't very useful for us. It's too small and difficult to see, but there is a pop-out button on the right-hand side. So I can click out the pop-out button, and it's going to show me the application full screen in my browser. Now, there's one small problem here. If any of you are familiar with something called CORS, the cross-origin issues that you get inside of browsers, and also the fact that if you're using HTTPS, it has to be HTTPS everywhere. We would have an issue with that at the moment because this application, just a sample application, is not using HTTPS. So you need to get rid of the HTTPS in front of the URL and just enter the browser URL. So we get an HTTP non-TLS version. All right, so here we have the login screen for our application. I need to sign up by creating a user. So I'm going to create a guy called James and give him an email address. I think the username has to be 4 characters or longer, so make sure you use at least 4 characters. And what happened behind the scenes there was that the user James was added to the Fabric CA. So behind the scenes, we called the Fabric CA and we registered and enrolled a new user with the Fabric network. Now here is my application. It allows me to donate money to a non-profit organization. And down the left-hand side of the page here, I have a number of non-profit organizations. You can see for each non-profit organization a little bit of information about them, what it is they do. We have a gallery for the non-profits, so you can get some idea of what that non-profit is doing. You can see the total amount of donations that have been donated to this non-profit, and you can see how much of those donations have been utilized, and you can see what that money was spent on. You can also see the total number of donors that have donated money to this particular nonprofit, and you can add or donate further money to this nonprofit. So if you are a books person, you like reading books, you want to donate some money to this charity over here, you can donate $250. Now, before I click the donate button, just keep an eye on this, the blocks appearing at the top over here. If I click on the donate button, what happened is $250 is going to be donated, and you might have noticed another block appeared here, block number 62. it's probably likely that my transaction for the donation was in block number 62. In fact, if you're interested, you could come into Cloud9, you could come into this window here, and if you look at, I can actually close that. If you actually look in here, you'll probably see some information on, you can see everything that's really happening behind the scenes. In fact, here you can see my user, James, my new user, interacting with the blockchain network. You can see that I've received block number 63 here. So you could probably figure out which block your transaction went into, if that was something that would interest you. And you can see that additional blocks have joined after block number 63. So we've had 64, 65, etc. What I have in the chain code is I have a function or a method in there that is actually spending your money, right? So as you donate money to these charities, the money is being spent by this function, which just randomly assigns money to different charities. And that results in a transaction on the blockchain network, and that transaction is recorded in a block. So that's what we're seeing over here. That's why we're seeing additional blocks added to the network. Okay, so you are free to explore that application at your leisure. It's a fully functioning application. Let me just quickly go through the summary. We've reached the end of the webinar, and I just want to summarize quickly what we've actually discussed so far. So what have we done in today's webinar? In today's webinar, we have announced GA of Amazon Managed Blockchain for Hyperledger Fabric. So it is now generally available in US East 1 for you to use. We stepped through a hands-on lab where we created a Fabric network on Amazon Managed Blockchain. On top of that network, we then deployed a RESTful API server, which was a Node.js application using a connection profile to talk to our Fabric network. Then we deployed a web application on Cloud9 that calls the RESTful API. And we did some discussion along the way on where the Fabric components are located and how you would typically interact with the Fabric network. And we discussed Chaincode and how to use the Fabric SDK. So that is the end of the webinar. Thank you very much for joining today. I hope you find it interesting. Please check out the GitHub repo and the blog posts for further information and try this out yourself. My name is Michael Edge, blockchain architect with professional services, and thanks for attending the webinar today.